Hello, everybody. So I'm doing something a little bit different today. We're taking a short break from the Nobel laureate videos. Going to do more of those. They're still coming. I'm doing some editing, but they are coming soon. Somebody asked me a question about, hey, if you took the mass of the sun or the mass of the Earth and turned it into a black hole, how big would that black hole be? And first off, what the heck is a black hole? So let's take a quick kind of look at it. Now, uh, planets as black holes is what I'm calling this. All right. So a black hole is essentially a very large gravitational mass. A whole bunch of mass got together in one place, and this is an artist rendering. Um, the and no, it's got so much gravity because of the condensed mass that's there. Nothing can escape, including light. We've seen it in the movies. It's been talked about, but there's a lot of research going on around these things because they come in different sizes. What makes a big one? What's a small one? How big do they have to be to form? All that kind of stuff still going on in the science community. Don't worry about any of that. The important thing to note is that the event horizon space is that edge right around the black hole itself. So as soon as you're trapped into its gravity, that's the event horizon spot. And like I said, this is artist rendering. Nobody gets that good a picture of them. Do we actually have we actually seen them? Well, sure. There's a picture of a real one. And I believe that one's out of the galaxy M87. It's a supermassive black hole at the center. You can see in the center there, it's what they look like coming through a telescope, thanks to the folks at the Event Horizon Telescope collaboration team. Now, how big are they? So let's take the mass of our sun, right? And say, okay, the mass of the sun is turned into a black hole. How big would the black hole be if it only had this mass in it? Just to try to give you an idea of how big a black hole is, because some of these things are super crazy massive by comparison. Well, our sun would be 6,000 meters, or roughly 18 modern aircraft carriers from one side to the other, if it were condensed down into a black hole. Not very big. Now let's look at the other planets. Mercury, zero point 0.9 millimeters. Venus, 14 millimeters. Earth, 18. Jupiter comes in the biggest at 5,600 millimeters, 5.6 meters. Not even twice the height of an NBA basketball hoop. So if you put two NBA basketball hoops on top of each other, Jupiter smaller as a black hole. 1.6 meters, 1,680 millimeters for Saturn. 300 millimeters for Neptune, yeah, 260 millimeters for Uranus. Not terribly big, right? So if you look at these things, I mean, Mars, come on, we got mosquitoes here in Texas that are bigger than that. Shoot, we got probably mosquitoes in Texas that are bigger than Earth as a black hole. But see, that's how much mass we're talking about. If you crunch it all down, that's how dense we're talking about. It's how much gravity we're talking about. If you crunch it all down, these things are not very big. What does that mean? How do you crunch that much space down? Well, that's another thing I still struggle with. Sure, you can get the interatomic distances to be less. Two atoms get closer and closer together, but how do you get those electrons in closer and closer to the nucleus? How do you really get that to happen without really weird things happening? So, black holes are really, from a physics standpoint, if you want to understand what's going on inside of them, that's still, to me, I think there's a lot of unanswered questions there. We understand what they are. We understand a few things about them, but what are the dynamics? How does physics behave inside one of them? Um, and I'm not convinced that the theories that are out there are correct. But somebody asked, so I wanted to put this together. Quick little video on just how big are the different planets if that equivalent mass was turned into a black hole, and the answer is not very, because you really have to crunch it down and really have to get it into a small spot. But anyway, thanks for tuning into this short one. We're going to get back to the Nobel laureate stuff later today. Everybody have a great day, and don't forget to click like and subscribe. And if you do have any questions that you feel like getting an answer to, and if I can, I will answer them. I'll do a quick video on it. Just feel free to throw them in. Direct message, at me on any one of the systems. Leave it as a comment. I'm happy to always try to answer questions as they pop up. That one came up, and I thought I'd give it a shot. So the answer is the planets are tiny as black holes. Have a good one.